Now, we'll illustrate what OS does when you specify pass as a disposition and how OS retrieves a passed data set. These parameters specify the retrieval of the data set named payroll. It's cataloged, you can tell, because unit and volume aren't coded. Pass is specified as the disposition. What does this disposition of pass cause? At the end of the step in which pass appears, OS builds this table in main storage. In it, it stores the data set named payroll, and unit and volume information is made effectively available via the table. So between step 1 and step 2, the DS name, unit and volume information is retained in main storage. Now, this coding in step 2 retrieves the passed data set. The disposition defaults to keep here, and unit and volume information for the retrieval is obtained by OS via the table using the DS name to find them. The table is called the passed data set queue, or PDQ for short. The PDQ looks like the system catalog, doesn't it, in regard to being a source for unit and volume information. OS references the unit and volume in the PDQ by a lookup on the DS name, as we said. This is also the same as for the system catalog. So, what else is the same? Well, the coding to retrieve via the PDQ and the catalog is also identical. So how does OS know which it is to use for a retrieval, the catalog or the PDQ? Well, when OS sees this DD coding, it knows that it must get unit and volume information. And first, it searches the PDQ using the DS name payroll from the DD statement. If OS gets a match in the PDQ, it gets the unit and volume information from there. If OS doesn't find an entry in the PDQ, it then searches the system catalog. If OS finds an entry in the catalog, it gets unit and volume from there. And if OS doesn't find an entry in either place, can it possibly locate the data set? No, it can't, because it can't get the device address from the UCB without the unit and the volume information to look it up. So you've seen that pass causes this entry to be made in the PDQ, and that when only DS name and disposition are coded for a retrieval, that OS will look to the PDQ to get unit and volume information. What happens to the PDQ at job end? The PDQ is not kept beyond a job, and at job end, it is automatically deleted. Therefore, OS constructs the PDQ each time a job is run, and when no data sets are passed in a job, OS doesn't construct a PDQ at all. Contrast the PDQ with the system catalog in regard to longevity. The catalog is a permanent data set and can be referenced by all jobs, whereas a PDQ can be referenced only within the job in which it is created. So you can pass data sets, but why should you? Well, passing can save time, and passing is an absolute necessity in one instance. Passing saves computer time. A data set that is passed in a step remains allocated at the end of that step, ready for use in a following step. Passing therefore saves data set allocation time. Data sets that are not passed, ones that have a disposition of keep or catalog rather than pass, are deallocated at step end, and OS has to repeat the allocation process for these data sets in each step that retrieves them. Passing saves your time. because you don't code unit and volume to retrieve a past data set. So there's less coding and therefore are fewer coding errors to debug. Now, for the instance when passing is an absolute necessity. This is when you specify a data set creation and omit the volume parameter to have OS select the volume. This is often done for temporary data sets. The problem arises in step 2, where we attempt to retrieve this data set. For retrieval, we need the volume information to specify where OS can find the volume. And we simply don't know the volume that OS selected for the data set. So what's the solution? Specify pass in step 1. This makes both unit and volume information available to step 2 via the PDQ. And thus the 4 items necessary for a retrieval are available to OS. In conclusion, I think that if you will visualize the PDQ as you code to pass and to retrieve past data sets, that you will have no trouble coding to pass a data set and then retrieve it. Now stay tuned. We'll be back with the next topic in a moment. Our final topic is temporary data sets. There are 2 occasions when you should use temporary data sets. One is when you need temporary storage, and the other is when you need to pass an intermediate result developed by one step of a job to a following step in the same job. We'll illustrate both of these situations in a moment. Right now, in a word, a temporary data set should be used whenever you wish to store a result that is merely intermediate to obtaining a final result. What are the advantages of using temporary data sets? There are 2. One is that temporary data sets can't be inadvertently kept to clutter your volumes with useless intermediate results. OS automatically deletes all temporary data sets at job end. A significant advantage. Even more significant for the programmer is the second advantage. Every data set should have a unique name. With perhaps thousands of data sets in an installation, it's no small task to ensure that the name you give a data set is indeed unique. No problem when a temporary data set is used. The simple name, TR, in this example, will be expanded by OS to ensure that the name used internally is unique. Now to describe how temporary data sets may be used for temporary storage. But first, what is temporary storage? Here is an example. In processing source language statements, the assembler writes out a symbol table and other intermediate results to a data set on tape, or it can be disk for the purpose of temporary storage. Later, the assembler reads these intermediate results back in, completes the assembly, and writes out the final result, the object module. This data set was created and retrieved both within this step. Now when the object module has been produced, the intermediate results are of no further value and should be scratched. You can specify a data set to serve as temporary storage to hold intermediate results with this DD statement coding. This statement specifies a temporary data set on a tape device. It's temporary because that's what the absence of the DS name parameter specifies. And OS will give the data set a name, a unique name that will be used internally to create and retrieve the data set. We don't care what the name is. We won't be using it. How about volume serial number? The volume will be selected by OS. We don't really care where OS puts this temporary storage. Now, how about disposition? The default, when disposition is not coded, is to new delete, and that's exactly what's required here, because the data set is to be created, then retrieved, and then deleted, all within one program or job step. Suppose the temporary storage is on direct access. The space parameter would be coded in addition to the unit parameter. OS has no way to determine space requirements, and we must always code the space parameter for direct access dataset creations. So that's the use of temporary datasets for temporary storage. Now, I want to illustrate a situation where it's appropriate to pass intermediate results from step to step within a job. Then, we'll discuss how to code DD statements that specify temporary datasets to be used for that purpose. The three-step job to compile, link, edit, and test a program is a common example of a need to pass results between steps of a job. Here you see represented those three steps: assemble, link, and test, called the go step. Let's look at them one at a time. The assembler produces the object module. The link edit program uses the object module as input and produces an executable program called the load module. The load module is executed in the go step. Operating on test data, it produces test results. You analyze the test results to detect bugs in the program, and then change the source program to eliminate the bugs found in that test, and then repeat the whole process again and again until the program is debugged. Let's view that process one more time. The assembler processes source language statements to produce the object module, which is used to produce the load module, which is then executed in the go step. Operating on test data, it produces test results, which we analyze for bugs, and then we revise our source statements accordingly. The point is that during testing, the object module and the load module produced by the assembler and link edit steps are merely intermediate results on the way to obtaining the test results. The purpose of this data set is simply to hold the object module until it is used in the link edit step. Then it's scratched. The purpose of this data set is simply to hold the load module until it is loaded for execution by the go step. Then it is scratched. The output that we finally carry away from the job then is the test result. So in the testing situation, we should view the object module and the load module not as final results, but merely as intermediate results on the way to obtaining the test result. Where the object and load modules are intermediate results, temporary data sets should be specified for them. Now that we have the situation in mind, we're ready to look at how to code to specify data sets for the object and load modules in this three-step job to compile, link edit, and go. In the assembler step, the object module is specified with these DD parameters. Creation of a temporary data set on tape is specified here. The temporary name object will be used to retrieve the object module in the next step. OS will select the volume since we didn't specify one here. Pass causes the unit and the volume used to be available via the pass dataset queue to the next step. In step 2, the link edit step, the object module is retrieved for input by these DD parameters. The DS name object is used by OS to look up the PDQ entry to obtain the unit and volume information put there in step 1. The object module dataset now has served its purpose, and at the end of the link edit step it is of no further value. Therefore, delete is its disposition. The output of the link edit step is the load module. The load module must be on a direct access device because it is a program and must reside in a program library, which we know must be in a partitioned data set on a direct access volume. creation of the load module is specified in the link edit step by these parameters. This form of DS name designates that we want a partition data set created. This PDS will be temporary because of the ampersands. It will be named load and will have one lone member named A, which is our load module. The coding of the space parameter is appropriate for a PDS. You may recall that this coding asks for 9 records, 1,024 bytes long each, and space is to be expanded in increments of 2 records if 9 isn't enough. And 1 directory record is requested for the PDS. As usual for temporary data sets, the volume parameter is not coded to have OS select the volume. Pass makes unit and volume information available to in the PDQ to the next step, the go step. Now, in the go step, the load module is retrieved using a backward reference in the execute statement. You recall that an asterisk is used to specify a backward reference. To complete the backward reference, we need the name of the DD statement in the link edit step that specified the creation of the load module, and that DD name was syslmod. This DD name and the name of the link edit step completes the backward reference here. DD statements to specify the test input and the output test results are required also, but we won't discuss those here. Well, that completes the illustration of when it's appropriate to pass intermediate results between steps of a job. A temporary data set should be used for that purpose, and we've shown the coding that would accomplish it. To summarize, you should use temporary data sets to store intermediate results within a program. And you should use a temporary data set when you need to pass an intermediate result from one step in a job to another following step in the same job. To conclude our discussion now, the question to be answered was, when do you code these parameters to create and retrieve data sets? To create or retrieve either temporary or permanent type data sets? The answers: for creation of a permanent data set, code them all. OS would select the volume, but we code volume because we usually want to plan which volumes permanent data sets go on. For temporary data set creation, we could code them all, but usually we don't. We don't code volume because usually we don't care where OS chooses to place a temporary data set. The parameters highlighted here are usually coded to create a temporary data set that is to be passed to another step. And you recall that we code just unit or unit and space for a temporary data set that is to be created, retrieved, and deleted all in a single step. In regard to retrievals, to retrieve any data set, either temporary or permanent, we code these 4 parameters. Unless what? Unless the data set to be retrieved has been cataloged or passed, in which case we code DS name and disposition only, and OS gets unit and volume from the catalog or PDQ. That ends the video portion of our discussion. The question of which DD parameters should you code is also answered in flowchart form in your workbook, Section G. Continue now with the topic entitled Review in Section G of the workbook.